Good day, everyone. Welcome once again to our session for today. So, we are going to discuss the last example for this topic, our introductory part of our discussion on Mechanics 102. Here's the last example, example number 8. A car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Determine the acceleration of the car. Okay, so to help us analyze this problem, class, it's better for us to make some illustration, no? Like this one below. So we have car at rest. So assuming that car at rest at this particular point, assuming this is the road, so car at rest at this point, okay, and accelerates uniformly over a time of 5.21 seconds. So assuming that the car accelerates in this direction, all right, and the time spent to reach from this position at rest is equal to t equal to 5.21 seconds, traveling this total distance of s equal to 110 meters. So now we are asked to determine the acceleration of the car. Acceleration of the car. So given in this problem, so writing down the given, so we're given the time, which is 5.21 seconds, traveling a total distance which is s equal to 110 meters. And we are asked to find the acceleration. So we are asked to solve for the acceleration of the car. Alright, so similar to our previous examples, it's better to write down the formulas that we need to solve this problem. So the formulas, we have velocity at any given instant of time is equal to the initial velocity, then plus the acceleration times time. And displacement s is equal to initial velocity v sub 0 multiplied by the time, then plus 1/2 times the acceleration multiplied by the square of the time. And the third one, square of the velocity at any given instant of time equal to the square of the initial velocity plus twice the product of the acceleration and the displacement. Okay, so which do you think among these formulas that we will use? So if you look at this, so we don't have, if you use formula number 1, so take note that we need to solve for A, right? So we don't have the final velocity, we don't have the initial velocity, but we need initial velocity using this illustration here is equal to 0, but still we don't have V, so we cannot use this one. But if we are going to use the second or the third, if the third, so we don't have, we have S, we don't have the velocity, the final velocity or velocity at any given instant of time, so we cannot use this. So the only formula that we can use is this one, because we're given S t equal to 0, initial velocity is equal to 0. So our equation will be reduced to s equal to 1/2 at squared. T is given, so therefore we can use this. Okay, so using this formula, s equal to initial velocity multiplied by time plus 1/2 times the acceleration times the square of the time. From our illustration, so at rest, the initial velocity at rest is equal to 0. Okay, so 0, so the whole thing here, the first term, becomes 0. So equation now reduces to s equal to 1/2 times the acceleration times the square of the time. Alright, so take note that we need to solve only for a. So from here, so solving for a, you just cross multiply or multiply both sides by 2. So when we multiply both sides by 2, so we have 2s equal to, so the right side multiplied by 2, we have 2 at the denominator, 2 at the numerator, so this will be 2 divided by 2 equal to 1. So what is left here is a times t squared, or it's just like you are cross multiplying 2 to the left. Okay, now to solve for a, so if we are going to divide both sides by t squared, so what we will have is 2s divided by t squared equal to a t squared divided by t squared. So t squared divided by t squared is equal to 1. So we have on the right side, we have a, which is the item that we are looking for, and we have 2 times s on the left side divided by t squared, or a equal to 2 times s divided by t squared. Then substituting the given, so 2 times s, our s is 110 meters divided by t, our t is 5.21, then squared. So our a therefore is equal to, using your calculator, so our a is equal to 8.10 meters per second squared. Okay, so this is our answer for this problem. Okay, thank you very much. If you have any question, you may just send your comments below, and see you in our next topic. So bye for now.